Looking at the power switch box. The power switch box is mounted in the base of the radome, and on the left side we have the connectors where the coax connectors from the below deck unit are connected. By default, these switch boxes are terminated with adapters from N to F in case you need to terminate your cable with an F connector, but we prefer to have a cable terminated with N connectors. The connectors on the power switch box, they are 50 ohm N types, so preferably you run 50 ohm cable from below to the above deck unit. Two coax cables, TX, RX. The TX cable, it will have also 48 volts on it to power the buck, and the RX cable will have 27 volts on it to power the system. And of course the RX cable will bring the RF signal from the LNB down to the modem, and the TX cable has the TX signal which goes into the buck. On the other side, cables. First cable, it's an SMA connector, and that cable goes to the rotary joint, and from the rotary joint it goes to the buck, transporting the TX signal. Inside this power switch box we get the 48 volts from the incoming cable, and it will be splitted, and on the second connector, the buck power cable connector, that connector is then connected to the slip ring and will bring the 48 volts through the slip ring into the buck. Then on the other side we have the antenna power connector, which is the second channel on the slip ring, bringing the 27 volts into the system. And we have the second channel of the rotary joint for the RX signal coming down, but also communication from the ACU towards the system is going over the same coax connector. Then we have LEDs, 3 bright LEDs to assist you when you have problems in the night. Have some light inside the dome, and there's a separate switch switching the LED on and off. And then there is the power connector, which is your safety connector. If you work on the system, you can switch the antenna off and on if needed. The system block diagram, basically we can divide it in 2 parts. The left side, the radome and all equipment which is inside the radome. On the right side, the modem and ACU, your below deck unit. Starting at the modem, TX line from the modem enters the ACU, the green line, and comes out of the ACU, the green line on the end connector, and on that point you will have 48 volts combined with the TX signal entering the radome, entering the power switch box. And inside the power switch box, this 48 volts is separated again from the TX signal. TX signal will pass the rotary joint straight into the buck. The 48 volt goes via the slip ring into the main control unit, comes out of the main control unit again and goes into the buck. The output of the buck, the green line, into the OMT, which is powering the antenna and transmits the signal into the atmosphere. Looking from the other side, RX entering the dish, then subreflector entering the LNB, and from the LNB, this can be the copol LNB or the crosspol LNB, the signal goes into the signal detector, which can be the MBD receiver or DVB receiver, and then the signal travels down into the FSK modem, through the FSK modem into the switch box, and from the switch box it goes down to the FSK in the ACU. From the FSK board the signal comes out again and then enters the modem. Now on the end connector from the ACU towards the radome, the RX signal is combined with the communication between the ACU and the FSK modem inside the dome. On the same cable, the RX signal will be present and 24 volts powering the antenna. The 24 volts powering the antenna enters the switch box, is then separated again from the RX signal, passes the slip ring into the MCU and then powers the whole antenna. Between the MCU and FSK, of course, there is communication for FSK MCU, and the yellow line indicates the MNC line, which allows you to maintain and control the buck from the ACU as well. From the modem, there is a connection between the modem and the ACU, and depending on modem type, this can either be Ethernet, can be a console cable, or it can be an RS-232/422 cable. In this situation, it's Ethernet, indicating a iDirect modem or Comtech VACP. Last, the power supply for the ACU, 110 volts to 220 volts. So the whole antenna is powered from the ACU, and there is no separate power supplies going to the antenna itself. It's running on 2 coax cables.